These are solutions to Calc 1, exam number 2. Number 1, you're basically doing a lot of y2 minus y1 divided by x2 minus x1. And one of the points is the origin, so you're just going to be subtracting 0. So essentially 1a is sine of 1 minus nothing over 1 minus nothing, 0.841471. B, sine of 0.1 minus nothing divided by 0.1 minus nothing, 0.998334. C, sine of 0.01 minus nothing over 0.01 minus nothing, 0.999983. And D, sine of 0.001 minus nothing divided by 0.001 minus nothing, 1.000000. So the estimate for the slope of the tangent line is 1. Seems like we're getting very close to 1 here. And maybe just for fun, I'll show you how one of them would work. How about I'll show you letter C, sine of 0.01 divided by 0.01. So C, sine of 0.01 divided by 0.01, 0.999983. Okay. And so all the others work in a similar fashion. Number 2, the limit as x approaches 2, that's two-sided. Two-sided limit. So coming from both the left and right, we approach 3, but f of 2 is -1. So f of 2 is -1. That's a dot down here, but we approach from the left and the right 3. So here's an example. The graph would come this way or this way or whatever, as long as it's a function and approaches something like this. Number 3, limit as x approaches 3 from the right. Okay, well, you're going to get a very small number. If I plug in 3.00001 squared, it's a little bit above 9. Subtract 9, it's a small number. ln of a small positive number approaches -infinity. So ln of a small positive is a large negative. Think back to the graph of natural log of x. It looks something like this. So the answer is -infinity. Number 4, the trick is to multiply by the conjugate of the denominator, 3 plus radical x over 3 plus radical x. So leave the top alone. The bottom comes out to be 9 minus x. And that very conveniently cancels this 9 minus x. So we have the limit as x approaches 9 of 3 plus radical x. Now I can just plug in 3 plus square root of 9 is 3 is 6. Number 5, limit as x approaches 2 of 5x equals 10. Given epsilon greater than 0, find a delta greater than 0 such that 0 is less than absolute value of x minus 2 is less than delta, implies absolute value of 5x minus 10 is less than epsilon. Okay, so first we do the scratch work. Scratch work is to work on this side. So absolute value of 5x minus 10 is less than epsilon. Factor out the 5, divide by 5. So absolute value of x minus 2 is less than epsilon over 5. I notice the left-hand side now matches what I have here. So that means just simply let delta be epsilon over 5. So let delta equal epsilon over 5. So now the actual proof, 0 less than absolute value of x minus 2 is less than delta, implies, double arrow here, implies, drop to 0 normally, change delta to epsilon over 5, that implies multiplied by 5. 5 absolute value of x minus 2 is less than epsilon, distribute, absolute value of 5x minus 10 is less than epsilon, that's the end of the proof. That's what we were trying to show. So this does imply this. Number 6, f of x is 3x, that's linear. Slope is 3, goes through the origin, but since x is less than 0, I have an open circle at the origin, and then the graph goes like so. And then this one, 2x minus 1, x is greater than or equal to 0, so when x is 0, y is -1, slope is 2, goes up something like this. And the graph is discontinuous at x equals 0. Okay, 7 is the trick where you divide top and bottom by x squared. This is second degree, this is second degree, so divide top and bottom by x squared. So limit as x approaches infinity of 2 minus 5 over x minus 2 over x squared divided by -3 plus 7 over x plus 5 over x squared. So when x gets big, this, and this all approach 0. So you have 2 minus 0 plus 0 over -3 plus 0. Final answer is -2/3. Okay, number 8, multiply by the conjugate. Again, radical x squared plus 1 plus x divided by radical x squared plus 1 plus x. So the numerator, that's like a minus b, a plus b. It's a squared minus b squared. A squared is x squared plus 1 minus b squared is x squared. X squareds cancel out. So you have limit x approaches infinity of 1 over radical x squared plus 1 plus x. And now when x gets big, this gets big, this gets big. Big plus big is big. 1 divided by big approaches 0. So the answer is 0. Number 9, velocity means derivative. So I have to find the derivative of 40t minus 16t squared. So y prime is limit h approaches 0 of 40 times t plus h. Every time you see t, make it t plus h. Minus 16 times t plus h squared minus f of t, the original function, 40t minus 16t squared, all over h. Now some messy algebra. Limit h approaches 0, 40t plus 40h minus 16, parentheses, t plus h squared is t squared plus 2th plus h squared. And distribute here minus 40t plus 16t squared all over h. Distribute the negative 16. 40t plus 40h minus 16t squared minus 32th minus 16h squared. I made a mistake, that does not cancel. Minus 40t plus 16t squared. Okay, so what I do cancel is the 40t's right here. And the 16t squareds cancel out. So I have this one, and this one. They all have an h. So you factor out the h. So I have limit h approaches 0, h paren 40 minus 32t minus 16h all over h. H's cancel out. Now when I plug in h is 0, that's gone. So I have 40 minus 32t is my derivative, which is the velocity. Okay, and now they tell me to plug in 1. So I just plug in 1, 40 minus 32, 8 feet per second. Finally, number 10, find a derivative using the definition of derivative. Again, do not use any shortcut. So f prime of x is limit h approaches 0 of x plus h cubed minus x cubed over h. Got a little timeout here. Figure out x plus h cubed. That means x plus h squared times x plus h. X plus h squared by root is x squared plus 2xh plus h squared. Then I multiply by another x plus h. So x squared times these two is x cubed plus x squared h. Then 2xh times these two is 2x squared h plus 2xh squared. And then h squared times each of these is xh squared plus h cubed. And these two combine. So I have x cubed plus 3x squared h plus 3xh squared plus h cubed. Okay, so I'm going to replace this thing now with this. So I have limit h approaches 0 of x plus h cubed, which is now x cubed plus 3x squared h plus 3xh squared plus h cubed. In other words, all this stuff. Minus the x cubed all over h. X cubed cancels out. This one, and this one is left. They all have an h. So factor out the h. H parentheses 3x squared plus 3xh plus h squared all over h. H's cancel out. And so now I have limit h approaches 0 of 3x squared plus 3xh plus h squared. Now when h approaches 0, this goes to 0, this goes to 0. So the derivative of the function is just 3x squared. All right, so these are solutions to exam 2 of Milham's Calc 1.